Hello, algebra students. Mr. Lawrence here with your flipped lesson. This is the review for the test. I expect you to do your best. This is the last test of the quarter. Some of you have D's and F's, and you don't seem to want to take any steps to improve your grade. This is the last opportunity. Watch the video. Watch it more than once if you need to. Do the best you can. Here are the three things you're going to need to know how to do. 1. Solving systems by substitution. 2. Solving systems by elimination. 3. Solving systems of inequalities. This will involve graphing. Okay? So first we're going to go over substitution. So let's look at the red problem here. We'll call this problem number 1. Remember that in substitution I have to have a variable all alone. I'm going to decide do I want to solve for x in the first equation, y in the first equation, x in the second, or y in the second. In this case, I think it would be smartest to solve for either x or y in the second equation. I like to multiply by 2 because it's relatively easy. There's a negative involved. I'm going to go ahead and solve for y. So I'm going to subtract x from both sides, and I'm going to get y equals 8 minus x. I'm going to take that, 8 minus x, it's the same as y, and I'm going to put it right there. So I'm going to get 3x minus 2 times the quantity of 8 minus x. That equals 4. Next I'm going to distribute. A lot of you show that, but then you don't actually distribute. You have to do the distribution. 3x minus 16 plus 2x. How did I get plus 2x, Anna? I took negative 2 times negative x. You need to say it and do it. All right, I'm going to combine my like terms, and I'm going to get 5x minus 16 equals 4. Now, it's not enough to just sit and watch me do this problem. You need to pause the video and do it with me. You need to see if you're getting the same answers. You can't learn by just watching me. All right, I'm going to add 16 to both sides. I'm going to get 5x equals 20. I'm going to divide by 5. X is going to equal 4. So the x-coordinate of my solution is at 4. Now to find the y-coordinate, it's easy. I'm going to use this equation here. Y equals 8 minus x. Y equals 8 minus 4. Y must equal 4. These lines are going to intersect at the point 4, 4. Won't always work out that the x-coordinate and y-coordinate match, but in this case it does. All right, I'm going to come over here to problem number 2. And I think it would be easiest to solve, well, what do you think? Would it be easiest to solve for x in the first equation? Well, that should be a y there. Y in the first equation, x in the second equation, or y in the second equation. It doesn't really matter. I can solve for x in the first or y in the second. So I'm going to go ahead and solve for x in the first equation, and that will give me x equal to 8 minus 4y. Now I'm going to take this and I'm going to substitute it in here for x. I'm going to get 2 times the quantity of 8 minus 4x, 8 minus 4y, sorry, plus y equals negative 5. I'm going to distribute, and I will get 16 minus 8y plus y equals negative 5. Combine my like terms. Many are going to think you have 16 minus 9y. You do not. Remember, this negative right here, hold on, this negative belongs to the 8y. So I have a negative 8y and a positive y. And that's going to get me 16 minus 7y equal to negative 5. Subtract 16 from both sides. I'll get negative 7y, which will equal negative 21. Divide by negative 7. And and y is going to equal 3. Okay, now I need to solve for x, and I'll use this equation here. And so I'll get x equal to 8 minus 4 times 3. So x is going to equal 8 minus 12. X is going to equal negative 4. So these lines cross at the point negative 4, 3. That's the substitution method. Okay, the elimination method. Call this problem 3, and the blue one problem 4. And problem 3. Okay, remember, for elimination, I want to have my coefficients match, but be additive inverses of each other. In other words, I want them to both be negative 3 and positive 3 on y, say. Or perhaps I want my x coefficients to be 10 and negative 10, something like that. I am going to do the least amount of work possible. I notice that 2 and 4. 4 is a multiple of 2. I could multiply this bottom equation by a number to turn it into 4. It would be relatively easy to do. And actually, I'm not going to turn it into 4. I'm going to turn it into negative 4. How could I turn this 2y into negative 4y? Well, I could multiply by negative 2. If I do it on the left-hand side, I have to do it on the right-hand side. And so I'm going to bring down my top equation, 5x plus 4y equals 20. Now, when I distribute here over on the left, I'm going to get a negative 4x, a negative 4y, and on the right-hand side, I'm going to get 10. Going to add my two equations together. 5x plus a negative 4x is x. These cancel. 10 plus 20, 20 plus 10 is 30. The x-coordinate of where they cross is 30. Now to figure out the y-coordinate, I'm going to use one of the original equations. I'll probably use the 2x plus 2y1 equals negative 5 because the numbers will be a little bit smaller. So I'm going to take 2 times 30 plus 2y, that equals negative 5. 60 plus 2y equals negative 5. I'm just going to solve for y. Subtract 60 from both sides. I'll get 2y equal to negative 65. Y is going to equal negative 37 and a half. So these two lines cross at 30, negative 37 and a half. And there you go. Okay, let's look at problem number 4. This one's a little bit more work because I have to multiply both equations. And I like the fact that I have a positive 2y and a negative 2y. So I'm going to multiply the top equation by 3 and the bottom equation by 2. And when I do that, my top equation becomes 9x plus 6y equal to 36. My bottom equation becomes 8x minus 6y, which equals negative 2. 17x equals 34. Divided by 17. X equals 2. Now that I know that x is 2, I use one of the original equations. Substitute in 2 for x. Solve for y. So I'll use the top equation. 3 times 2 plus 2y equals 12. 6 plus 2y equals 12. Subtract 6. 2y equals 6. Divide by 2. Y equals 3. So these two intersect at 2, 3. Okay, I'm going to solve this system of inequalities by graphing. The black one was in slope-intercept form. So I'll plot the point 0, negative 3, my y-intercept. And then I'll rise 1, run 1. Rise 1, run 1. Rise 1, run 1. And it's going to be a broken line. Remember that, it's a broken line. It's going to be and put an arrowhead on there. All right, I'm going to use a test point. I'm going to plug in 0, 0. 0 is greater than 0 minus 3. 0 greater than negative 3? You betcha. So I'm going to go ahead and shade where my test point is. My test point was the origin, so I'm going to shade this way, above the line, in other words. Okay, now we'll do the blue one. Again, I'm in slope-intercept form. I'm going to plot the point 0, 5, 1, 2, 3, 4, 5, and I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. All right, it's going to be a solid line because it says equal to, and I'm going to use the test point 0, 0. Plug 0 in for y. I'll plug 0 in for x. And I get plus 5. So 0 is less than or equal to 5, which is true. So I will shade below the line because that's toward the origin. So I'm going to shade down here. Sorry, I'm going over a little bit. Having a little trouble controlling my airliner. The actual green portion shouldn't be above the line at all. It should be below the solid line and above the dotted line. Okay, so the solution region is actually all through here. Yeah, it should get really close to that line, but shouldn't actually cross it. Apologize for a slight error there. Okay, so one more. I'm in slope-intercept form for the black one. I know it's going to be a solid line because it says it's equal to y-intercept of 3, down 1, right 4, just using my slope, doing it again, 2, 3, 4. I said it was a solid line. Okay, and oh, I'm getting ready to shade, but I'm not ready to. I'll plug 0 in for y, and I get 0 is less than 3, which is true. 0 is less than 3, and I'm going to shade down here. Okay, this one here. This should be an easy problem. Look, it's in slope-intercept form, right? The y-intercept is 2. How do I know? Because there's no variable there. So, the y-intercept is 2. Slope is 0 because there's 0x in it. It's actually a horizontal line going through all the points where y is 2. So it's a broken line. Something like that. And then I'll plug the origin in. 0 is greater than 2. Is 0 greater than 2? No, it is not. So I won't shade the origin side of that line. I'll shade the opposite side. So in other words, I'm going to shade everything above. And you see the solution I get is that kind of triangular region off to the left of the y-axis. There you go. All right, that's your review video. I wish you well. I know that those of you that prepare, those of you that care, Kayla and Jake and Logan and Nicole and Ashley and Megan, those of you that care, Jacob trying to hang on to that grade that he's worked so hard to earn, you're going to be fine. I'm worried about some of the others. Some of the others who only care sometimes. If you're one of those people, do your best. Give it everything you have. It's your last chance to raise your grade. All right, Mr. Lawrence signing off. Good night, everybody.